1.7, inequalities. So when we're talking about inequalities, we're talking about relating one expression to the other using either greater than, less than, greater than or equal to, or less than or equal to. So we're saying that it's not specifically equal to each other, but that one may be greater or one may be less than. Sometimes we have a strict inequality, which means that it's greater than or that it's less than, or sometimes we have a non-strict inequality, greater than or equal to, less than or equal to. The first thing we're going to look at is linear inequalities, which are inequalities that can be written in the form ax plus b less than 0, or ax plus b greater than 0. And in this case, a and b are both real numbers, and a cannot be equal to 0, because as soon as we make it equal to 0, then we just have a constant less than 0, so a negative number, or greater than. Either way, it's not important as long as there is this inequality symbol, not equals. Now, when we're dealing with inequalities, we can solve them just like we have equations, but there's a couple rules that we need to realize. When dealing with inequalities, if we have a less than b, if we add another constant c, a plus c, that will also be less than b plus c. And you remember when we were dealing with the equations, we said the addition property said that if you add the same thing to both sides, then it's still equal. Well, for inequalities, it says if you add the same thing to both sides, then the relationship stays the same. If this side was less than that side, it will still be less than that side. Now, in equations, if we took a and multiplied it by some value, and took b on the other side and multiplied it by some value, then for equations, we said then that remains the same. If we multiply it by both same thing by both sides, or both sides by the same thing, then the equation is equivalent. Well, we're going to break that up into two pieces here with inequalities. If c is greater than 0, then if a is less than b, then a times c is going to be less than b times c. So I'm going to say, let me modify this slightly and say if I have a less than b and c greater than 0, then AC is less than BC. But if A is less than B and C is less than 0, so if it is a negative number, then A times C is going to be greater than BC. So basically what this is saying, the difference between dealing with the equation and multiplying both sides by the same thing and inequalities is that if you multiply both sides of an inequality by a negative number, the direction of the inequality will change. If it was less than to start with, it's going to become greater than. If it was greater than to start with, it's going to become less than. So let's do an example. Negative 2x plus 7 less than negative 5. So we want to solve for x and realize that when you're dealing with an inequality, you're no longer finding a single solution, but you are finding a range of solutions. So what we want to do is we want to get x by itself. So we're going to subtract 7 from both sides. So negative 2x is less than negative 5 minus 7. Or negative 2x is less than negative 12. And then we want to divide both sides by negative 2. Now, remember, dividing by negative 2 is the same as multiplying by 1 over negative 2 or negative 1 over 2. So that's essentially multiplying by a negative number. So if we divide both sides by negative 2, I'm not going to put that there because what's going to happen is we divide both sides by negative 2, that side becomes x. Because we're dividing by a negative, essentially the same as multiplying by a negative, then the sign is, the operator is going to change to greater than, and you get negative 12 divided by negative 2, or x is greater than 6. So any value greater than 6 should make this inequality a true statement. Well, let's try one. What about 10? Negative 2 times 10 is negative 20, plus 7, negative 13. Negative 13 is less than negative 5. Correct. That is true. Let's try something less than 6, since we say it has to be greater than 6. Let's try 0. We plug in 0, we get 7 less than negative 5. Obviously, that's not true. Now, when we're writing this, there are a number of ways that we could write this. We can use interval notation, and I could say that that is from x greater than 6, so it's from 6 to infinity, any number from 6 to infinity. I could write it in set builder notation, all x such that x is greater than 6. So that would be valid. So there's more than one way we can write this. A lot of times I prefer interval notation because to me, it's less wordy. It's a lot easier for me to just write it that way. But if we're going to be using interval notation, then we need to understand how those intervals actually work. So here, I'm going to build not so much a table, but I'm just going to give a little chart here of what's going on. So if x is less than a, that is a strict inequality. If x is less than a, then that means that we are going from negative infinity to a exclusive. Now, when you're dealing with interval notation, remember that a parenthesis means that you do not include that value. A square bracket means that you do include that value. So x less than a, that means that it's from negative infinity to a. Never include infinity. Infinity is a concept, so it never gets square brackets. So anytime you're using negative infinity or positive infinity, you're always going to use the parenthesis. Whether you use a square bracket or parenthesis for the other part of it depends on whether this can be equal to that value. And this says strictly that x must be less than a. So it approaches a, but it never touches a. If x is greater than a, then we have from a to positive infinity. If x is less than or equal to a, we have from negative infinity to a inclusive, because now we allow it to be equal to a. If we x greater than or equal to a, then we have a can be included, so we're going to start at a and go to infinity. Remember, we never include infinity. So that gives us less than, greater than, less than or equal to, greater than or equal to. Well, sometimes we have ranges. So we may have A less than X less than B. Both of those are strict inequalities. So that's the interval from A to B exclusive. A less than or equal to X less than B. Well, now we see that it does include A, but it does not include B. So the interval from A to B. Going the other way, what if we have, actually I'm not going to go the other way because we already set this up. So what if we have A less than X less than or equal to B? Now it does not include A, but it includes B. So from A to B inclusive. And A less than or equal to X less than or equal to B. So it includes both A and B. So we see a whole bunch of different intervals that we could have here. We could also have the interval of all real numbers from negative infinity to positive infinity. So X is all real numbers. So we could do that also. Also, things can get broken up where you have two intervals. Maybe you have X less than A or X greater than B. So we say X less than A or X greater than B, in which case we'd use our intersection or union. So in that case, you have X less than A. So that's from negative infinity to A. But we could also have, so union, X greater than B. So that's from B to positive infinity. So we can do a number of different things with that. Now, what I'd also like to add on here is on a number line what this looks like. Now, I like interval notation. It goes very nicely onto number lines. If you remember with number lines, there are a couple ways you can indicate whether something includes the value or does not include the value. One way you can do it, like here we have from negative infinity to A exclusive. On a number line, you could say it does not include A. So if that's A, an open circle says it's not included, and then an arrow to the left says it goes on forever that way. So you can do an open circle to that, or you can actually use the parenthesis or square bracket. So I could do that as anything less than A, and the parenthesis there tells me that it does not include A. In this, I can do anything greater than A, so I can say greater than A, or greater than A. If it includes equality, then that's where you either fill in the dot or where you use the square bracket. So anything less than or equal to A is filled in, and we've got the arrow, or we use the square bracket, and then we have the arrow. Doesn't matter which you use, as long as you use one or the other and you use them properly. So a filled in circle means that the value is included, an open circle means the value is not included. A parenthesis means the value is not included, a square bracket means the value is included. So let's go to another example. In fact, what I'm going to do is I'm going to go to a word example. So I'm just getting here so I can get my PowerPoint slide up. So just give me a moment. And there we go. So we're going to look at the break-even point. So the break-even point, if the revenue and cost of a certain product are given by R equal to 45x and C equal to 30x plus 5250, where X is the number of units produced and sold, at what production level does R at least equal C? Well, R stands for revenue. That's the amount of money that's brought in. C stands for cost. That's the amount of expenses to make that. And what we see here is that obviously they're charging $45 per unit, or 45 of whatever they're using, whether it be euro, dollar, yen, whatever it may be. But they're charging each unit, they're charging 45. And the cost is 30x plus 5250. That 5250 is what we call the fixed cost. So no matter how many units they produce, they're going to pay 5250 out. Maybe that's the cost of leasing the facility that they run. So it's something that it doesn't matter whether they produce 1 unit or 1,000,000 units, that cost is going to be there. And then your variable cost is that 30x. So after they pay that 5250, for each unit they produce, they're going to pay out 30. So the break-even point is where you actually start making money. Because it would be obvious here that if you just produced 1 unit, you'd bring in 45 of whatever currency, and you're going to spend 5,280 of whatever. So obviously you're going to be losing money. So it's very important to know your break-even point. How many units do I need to sell to at least pay for my costs? And then beyond that, we can consider that to be profit. So X is the number of units produced and sold. What production level does R at least equal C? At what point do we bring in at least as much money as we put out? So let me put that on the board here. R is equal to 45x and C is equal to 30x plus 5250. Okay, and we want to know when R is at least equal to C. So that means greater than or equal to C. Now that's going to be one of the hardest parts when you're dealing with real world problems, is just recognizing what the inequality is. At least means that much or higher. At most means that much or lower. More than, greater than means above, less than, below. So we want to know when that's going to happen. So we're just going to set R 45x greater than or equal to C 30x plus 5250. So bring the variables over the same side. So I'm going to subtract 30x from both sides, and we end up with 15x greater than or equal to 5250. And then we're going to divide both sides by 15, giving us x. And 15 is positive, so we don't flip the inequality in this one. We're going to keep it the same. If this was negative and we were dividing by a negative number, then we would flip it. But since it's positive, we do not. So x greater than or equal to 5250 divided by 15. I grab my handy dandy calculator. One should always have a calculator on hand. 5250 divided by 15 gives me x greater than or equal to 350. So I need to produce at least 350 units to break even. Anything more than that, and I start making a profit. In this case, it turns out to be 350 units, literally breaks even. I don't make any money off of making 350 units. Now you may ask yourself, okay, if that's the case, does that mean if I produce 350 units and that's all I produce and sell, that I might as well just quit because I'm not going to make any money off of it? And that's an excellent question. So I'm going to give you a little philosophical answer for this, that's a break-even point. You are not losing money at that point. But what are you doing? You are providing employment to other people so they're making money. You are providing something that people want or need, so you are making people happy. And with all those fixed costs involved there, then you're actually paying out other things. So you're paying out the landlord or whoever owns the building. You're paying out the other fixed costs associated with it. So you're actually being a productive member of society, even though you're not making any money. So you may get into the question, well, gee, I'm not making any money off of it. Should I continue to do that at that level? Well, that's a decision you have to make. But that's an example of what we can do with inequalities for linear inequalities. Now, what I also want to do is a three-part inequality. Well, what's a three-part inequality? Well, I kind of showed it to you on the bottom over here at the one point where I said, hey, we could have this where x is less than this value or x is greater than this value. So you have this range. Well, a three-part inequality means instead of just having x less than or equal to something, we have x in the middle or some relation of x in the middle, and then we have inequalities on either side. So just to grab an example here, 1 less than or equal to 6x minus 8 less than or equal to 4. Now you may ask yourself, well, how do I do this? How do I deal with this? I've got three different parts. And that's exactly how you deal with it. Deal with three different parts. If I want to do something to this middle part, because remember the goal is to get x by itself, then do it to all three parts of the inequality. So in this case, I have 6x minus 8. So what I'm going to do is I'm going to add 8 to all parts of the inequality. So 1 plus 8 less than or equal to 6x, because negative 8 plus 8, 0, less than or equal to 4 plus 8. So now I've got 9 less than or equal to 6x less than or equal to 12. And now I want to divide by 6 to get x by itself. So I have 9 divided by 6 less than or equal to x less than or equal to 12 divided by 6, 9/6, 3/2. 3/2 less than or equal to x less than or equal to 12/6 is 2. So I have this interval and it includes those from 3/2 to 2. So if I take any value from 3/2 to 2, it'll make this inequality correct. So 3/2 is 1.5. 2 is 2, obviously. So let's start with 2 and see what happens. 2 times 6 is 12. Minus 8 is 4. 1 is less than or equal to 4. Yes, that's correct. 4 is less than or equal to 4. Yeah, 4 is equal to 4. So we're good. 3/2. 6 times 3/2 is 18/2, or 9. 9 minus 8 is 1. 1 is less than or equal to 1. Yep. 1 is less than or equal to 4. Yes. So we're good, and anything in between there will also be correct. So we can deal with a three-part inequality just by maneuvering in all three parts at the same time. If we have to deal with dividing by a negative, then that's going to swap both of the inequalities and still work the same way as if we were dealing with 2, we'll just be dealing with 3. So that's the first part of inequalities, dealing with linear inequalities.